हेलो गाइस, हाउ आर यू ऑल? कैसे हैं आप लोग? वेरी गुड इवनिंग टू एवरीवन. दिस इज योर KP sir Krishna Prakash in front of you today to teach regarding design of sedimentation chamber. Just the basics of design in very short duration, 20 to 30 minutes. I will make you to learn how to design a sedimentation chamber. Before starting of that, myself Krishna Prakash have 16 years of total experience, trained more than 150 batches for GATE and ESE, worked in most of the famous and top institutes in India, now teaching in Unacademy for the subjects of environmental engineering, hydrology, irrigation, construction materials and management, open channel flow. And if you want to watch my classes in Unacademy app, search KPCivil or NVLK Prakash. You will get all my profile, all my videos, special classes plus courses and everything. So you can watch and enjoy the all free special classes. Around 100 free hours I have taught in Unacademy app from the subjects of environmental engineering, hydrology, irrigation. So you watch and enjoy all my free classes. Along with that, you get more and more depth knowledge about the subject. Still, if you want to take plus course subscription, if you satisfied with my free special classes, if you want to take plus course subscription for full length GATE and ESE, then take plus subscription in Unacademy online classes. It is a live interactive sessions. So for live interactive classes, you want to directly talk with me through Unacademy app class, live class. Take plus subscription using a KPCivil code. You will get a 10% discount and other benefits. Okay. Don't forget about the code KPCivil. Refer KPCivil code to your friends, to your juniors to watch the free classes in Unacademy special classes. Okay. Now, today our discussion is how to design a sedimentation chamber, settling tank. We can call it now sedimentation chamber, settling tank. Do you know about these words now? Sedimentation chamber, settling tank, or clarifier. Just we are discussing in brief how to design a sedimentation chamber. Why sedimentation chamber is required? For settlement of any kind of particle. Sedimentation tank function is settlement of any kind of particle by virtue of their weight, density, specific gravity. That process is called sedimentation. We are considering here. So first I am going to write sedimentation definition. The physical unit operation. The physical unit operation it is a physical process. It is not chemical process. It is not biological process. All physical methods of treatments are called physical unit operation. Physical unit operation for separation of particles under the influence of who is influencing the particle to settle down or separate? Under the influence of, we are not providing any artificial force here. The particles are settled down under the influence of natural Gravitational force. Gravitational force is a physical force and attracted the particle to settle down. You understand? Gravitational force is a physical force that attracted the particle to settle down. So that physical unit operation for separation of particles under the influence of gravitational force by mass and density. Gravitational force attract the particles because mass and density of particle is called as sedimentation. Settling is called as settling or sedimentation, or the same process we call it as clarification. Settling or sedimentation or the same process we consider it as clarification. All are same. All are same. Okay. We are not differentiating anything. All the three words are same. Settling, sedimentation, clarification. In which any particle fall down, settle down under the influence of gravity due to their mass and density. That phenomena is called settling or sedimentation. Then the rectangular or circular chamber, rectangular or circular chamber in which sedimentation operation is carried out. Rectangular or circular chamber in which sedimentation operation is carried out. Operation is performed, carried out, is called as, now that is called as, tell me, means where you are sending the water, where particles available in water is settled down and water is coming out of the chamber. That chamber, total process of sedimentation operation is carried out, is called as settling chamber, sedimentation tank or clarifier. All are same. Settling chamber, sedimentation tank or clarifier. All are considered to be same. The process in which sedimentation operation is carried out is called settling chamber, sedimentation tank or clarifier. We are not here discussing the total theory about it. Only today we are going to discuss about design steps. Design concepts related to sedimentation. Just design steps of sedimentation. Determine length, width and depth of sedimentation or diameter of sedimentation tank. Just design steps we are considering. We are not here to discuss everything. Just we are discussing about design steps. So regarding sedimentation design, determining dimensions of sedimentation chamber, the first step we are going to consider is discharge Q. Discharge Q is equal to. So we are designing this sedimentation chamber for supplying water towards a city. So that discharge is nothing but water supply needs of the city. What we can take? Population into per capita demand. So discharge according to population water needs. So we'll consider discharge Q is equal to population into per capita demand. Per capita demand is liter per person per day, liter per capita per day into population. So we will get a discharge in the units liter per day. We'll get a discharge in the units liter per day. Now, after knowing the discharge, second step, we are considering surface loading velocity, overflow rate. In GATE and IS or other exams, they are providing different words related to it. Surface loading velocity, overflow velocity, overflow rate, overloading rate. The different words, just same parameter, same phenomena, just they are giving you different words. Overflow velocity, overflow rate, surface loading velocity, surface loading rate, different words. But finally, all are the words, alternate words given here, they will represent this finally one parameter V0. Design velocity, in simple design velocity. So this is nothing but, we'll consider V0, the volume of water loaded into unit surface area. Whose surface area? Whose unit surface area? Volume of water loaded into, flown through, or simply you take flown through, volume of water flown through 1 square meter surface area, unit surface area of sedimentation tank. Sedimentation tank in unit time. In unit time means volume of water flown through 1 square meter area in 1 hour time duration. Unit time you may take 1 hour, 1 day, 1 minute, 1 second, that is up to you. But if you have taken a square tank of 1 meter length and 1 meter width, how much water is flowing through it within 1 hour, 1 day, unit time? That is called V0 value. Volume of water loaded into unit surface area of sedimentation tank, unit time, is called as overflow velocity, overflow rate, surface loading velocity, V0. So we can write it down. How can we write down? How can we write down? Tell me V0. Volume of water flown, volume of water loaded, volume of water flown, volume of water loaded per unit surface area per unit time. Per unit surface area per unit time. V0 is equal to volume of water loaded per unit surface area in unit time. So what is volume by time? This is volume divided by time. Discharge. So we'll consider V0 is equal to discharge by surface area. Which units it is representing? You may take discharge liter per hour, surface area as meter square, or you may take discharge meter cube per day, surface area as meter square. So V0 expressed in the units of liter per hour per meter square, meter cube per day per meter square. V0 is equal to Q by SA. But remember, we are not at all considering or calculating V0 value. We are taking V0 value from IS code. According to IS code, for primary sedimentation tank in water treatment, V0 is taken as. What is the value of V0 for PST in water treatment? According to IS code, for primary sedimentation tank V0, 500 to 750 liter per hour per meter square. 500 to 750 liter per hour per meter square, or tell me, or any other value? 12 to 18. Just unit conversion I am taking. Liter per hour to meter cube per day. Meter cube per day per meter square. 500 to 750 liter per hour per meter square, or 12 to 18 meter cube per day per meter square for primary sedimentation tank, that is V0 value. If you are designing secondary sedimentation tank, if you are designing SST, secondary sedimentation tank in coagulation, water treatment plant coagulation, secondary sedimentation tank, V0, 1000 to 1250. 500 liters of water increasing. 500 to 750 modified to 1000 to 1250. 500 liters of water increasing. 1000 to 1250 liter per hour per meter square. Same. 24 to 30 meter cube per day per meter square. 24 to 30 meter cube per day per meter square. So for primary sedimentation tank, V0 is 12 to 18 meter cube per day per meter square. For secondary sedimentation tank, V0 is 1000 to 1250 liter per hour per meter square. So what is the meaning of this? You are selecting any one value. You are not taking, you are not calculating V0. You are selecting any one value. So you know V0 and you know discharge. First step, estimated the discharge. Second step, selected V0 value from the IS code. Now, surface area is equal to, tell me, this surface area. Surface area is equal to Q by V0. Surface area in meter square you are getting. Surface area in meter square you are getting. Simple. Discharge by V0. Discharge may be considered in liter per day. So you take V0 in liter per day per meter square. Or discharge may be considered in meter cube per day. You may consider V0 in meter cube per day per meter square. Depending upon the units you change, unit conversion is very, very important. Surface area is equal to Q by V0. You are getting. Now, after getting surface area, dimensions are needed. According to IS codal provisions, you consider length of primary sedimentation tank is maximum 4 times the width. L is equal to 4B. Length of primary sedimentation tank is, length is maximum 4 times the width. So, what you are getting? Means you may take L is equal to 2B, L is equal to 3B, L is equal to 4B. Not more than 4 times. Clear? Not more than 4 times. L is equal to 4B. So, in surface area I am substituting. Surface area is equal to LB. L is equal to 4B into B, 4B square. Surface area is equal to 4B square. Now what is B? So B is equal to root of surface area by length width relation 4. 4 is nothing but ratio of length to width. Ratio of length to width, L by B value. Because L is equal to 4B, you take L by B is equal to 4 na? L by B is equal to 4 na? So that 4 I am taking. B is equal to under the root of surface area by 4. Ratio of L to B is taken. So if it is a rectangular tank, simple rectangular tank, L is equal to 4B, B is equal to under the root of surface area by 4. If it is circular tank, for circular primary sedimentation tank, for circular primary sedimentation tank, what we can take? Tell me, for circular PST, surface area is equal to pi by 4 d square. Surface area is equal to pi by 4 d square. So what is d now? D is equal to under the root of 4 into surface area by pi. 4 into surface area by pi. Capital D diameter is equal to under the root of 4 into surface area by pi for circular sedimentation tank. Got it? Now, what about depth? Depth is important. Depth is important because we determined here L and B for rectangular chamber and this is for circular chamber. Depth is very important. For any chamber, it may be circular, it may be rectangular. Depth is considered between assumed depth 3.5 to 5 meter. Depth of sedimentation chamber does not influence its efficiency. So you can take any value, assume, but that depth you consider here. First, freeboard, whose value must be taken as? Whose value must be taken as around 0.5 meter freeboard. Then settling zone depth or water depth. Settling zone depth or water depth, which is considered as a small h. Small h. Plus sludge zone depth. Sludge zone depth. The particles, impurities where they are settled and taking rest, that is called sludge zone. Sludge zone depth considered between 0.8 to 1.2 meter. So finally total depth capital H. So total depth of sedimentation tank capital H is equal to freeboard plus settling zone depth plus sludge zone depth. All the three combinedly we are taking 3.5 to 5 meter. All the three combinedly we are taking 3.5 to 5 meter. Freeboard plus settling zone depth plus sludge zone depth. 0.5 meter plus small h plus 0.8 to 1.2 meter. Total depth capital H we are considering. Okay. So we got the dimensions LBH or we got the dimensions capital D, diameter of the tank in under H. What you will get finally? Volume. Capacity of sedimentation tank. Capacity of sedimentation chamber. What is meant by capacity? Total size of the tank. Volume of the tank, V. Capacity of sedimentation tank is nothing but volume of the tank, V. V, that is simple, na? V is equal to LBH. V is equal to LBH. For rectangular chamber, for rectangular tank, V is equal to LBH. For circular tank, what is the volume? For circular primary sedimentation tank, what is the volume? We are not taking regular formula, special formula. D square into 0.011D plus 0.785H. Specially designed formula for sedimentation tank. We are not considering regular volume formula for circular sedimentation tank. for circular sedimentation tank. Volume is equal to d square into 0.011d plus 0.785h. So we got everything: surface area, volume, length, width, depth, diameter and depth. All values considered, determined using this. What you need for this? 2. Only 2 na? Discharge using population into per capita demand. Velocity from IS code 500 to 750 or 1000 to 1250. Using this you get surface area. After surface area, L is equal to B, L is equal to 4B, or surface area is equal to pi by 4 d square. Depth is assumed, you will get a volume. This is regarding design of sedimentation chamber. So I am going to teach Unacademy free classes, YouTube free classes, live classes. Refer all your friends to watch all my free classes. Tell them to take plus subscription if possible using my code KPCivil. Ask them to watch, follow me on Unacademy app, dedicate their hats in Unacademy app. And also, if you want to crack GATE and ESE in first attempt, follow my classes in plus course, not free classes. Free classes randomly we are taking, not in a continuous manner, you can't understand very well. So in full length course we are taking a continuous subject: environmental engineering 140 hours, hydrology 60 hours, irrigation 60 hours, open channel flow 30 hours, like that. What is needed for your exam preparation? In-depth subject knowledge we provide you. So join Unacademy plus subscription as early as possible using the code KPCivil. Don't forget about the code. You miss your benefits and 10% discount. Got it? You are going to miss your benefits and 10% discount if you miss KPCivil code. Okay? Spread the information. Done. Thank you one and all. I hope you enjoyed a lot regarding design of sedimentation chamber. Thank you one and all. Bye bye all of you.